Hello, my name is McKenna Joy Davis-Breton, and today we've got to sort them all, which means we'll be applying machine learning algorithms to the Pokemon world. This data that I'm using today is publicly available at kaggle.com, and it contains over 1,000 Pokemon species, each which has 8 features: type, which is a string variable, it's a word, and then integer variables, attack, defense, hit points, special attack, special defense, speed, and total strength. In order to work with the type string variable, I converted it to an integer by summing the alphabet index of every letter in each string type word. Once I had done that and I had all numeric data, I used peer review to look at feature relations, which is a free open source software. And I identified that speed versus hit points, highlighted in green, is a clumpy feature relation that would be good for a k-means classification algorithm. So I utilized a k-means algorithm to create 5 groups in this data. And the way this algorithm works is by first initializing the group centroid locations within the data range, then assigning all data points to the group which centroid they are closest to using Euclidean distance. Then the centroid locations are recalculated by averaging all of the member point locations. And then those labeling and centroid moving steps are repeated until there's convergence, which is that the centroids are no longer moving between steps, or you've reached some maximum iteration threshold number. And in this case, the algorithm did a great job of defining clear low, middle, and high scoring groups for HP and speed, and it's established that there's a trade-off between HP and speed, such that if you're high in hit points, you're probably not so fast, and if you're very fast, maybe not so many hit points. After that classification algorithm, I moved on to random forest regression algorithms using scikit's learn random forest regressor function. The max depth I determined based on trial and error for best performance. And here I tried to predict special attack using the other features. There is no closed analytical form solution for how to get special attack from the other features. There's no formula, so this is a great use of a machine learning algorithm. And as we can see, the algorithm performed well with fitting about a 73% accuracy to its training data, it's R-squared, and when including the test data, it still maintained about 73% for its out-of-bag score. We can see on the right here the feature rankings showing that type and attack were most important for special attack, and speed and total strength were not so important. Then I applied this random forest to total strength, because that does have a closed form analytical solution. It's the sum of all the other integer types data of the Pokemon. And I did not explicitly tell my model the analytical form solution. It had to figure it out on its own. And we can see that it was able to recognize this relationship. And there's a very tight feature fit with about 95% accuracy for the R score. And again, we were able to identify feature importances. Overall, in conclusion, I applied k-means classification and random forest regression algorithms to Pokemon data, successfully grouping Pokemon into 5 groups based on hit point and speed, feature relation, and also successfully predicting special attack and total strength using random forests. I hope you all enjoy this project. It was fun for me.